Hey scholars, welcome to section 5.4, which is how do communities and ecosystems actually respond to environmental changes. And so we're going to look at how these communities actually change, what causes them to change. That's what our focus will be on with section 5.4. So communities and ecosystems change over time. It's called ecological succession. It happens in two different ways. The first one is primary succession, and obviously the second is secondary succession. And so those are two major ways that actually the ecosystem can restore itself to become a more diverse and dominant community. So we're going to look at how that happens. So first off, some ecosystems actually start from scratch. This is called primary succession. This is the first one that we're going to look at today. And this is basically happening when there is no soil in the terrestrial system whatsoever. So no soil base, it's just basically bedrock, gravel, no nutrients, nothing. And ecosystems can be built upon this. There's no bottom sediment if this is an aquatic system, so it's basically bare rock on the bottom, no sort of sediment, no nutrients again at the bottom for plants to root in and grow. So that's what we call, those would be two different key features in both terrestrial and aquatic ecosystems where primary succession would take place. Early successional plant species are called pioneer species. And in this video, I'm going to go ahead and cut to a clip of this where I'm actually in the Grand Canyon and taking a look at a pioneer species that I want you to check out right now. So I'm here at a stopping point in the Grand Canyon, and within my biology classes we always talk about succession. And this would be called a pioneer species. It is the first species on inhabiting an area. These are called lichen. You can see the different kinds of them. There's green, yellow, lots of different colorations. But this is always a heavily EOC tested question. But lichens are your pioneer species, the first species to inhabit an area. And you can see they're growing on this this rock here, which is really no major nutrients as far as soil base. They have no roots. They just grow on and absorb what they can through the little bit of moisture that's collected in the air. So you guys take a look at the pioneer species down in the Grand Canyon, known as the lichen. That is a prime example of an early successional plant species that actually isn't even a plant. It's kind of a formation of two different types of species that coincide. And then eventually plants go on after that. There are mid-successional plants like bushes, really tall grasses, things like that. And then even late successional plants would be your trees, your oaks, the ones that last a very, very long time, like redwoods and sequoias. Those would be prime examples of very late successional plant species. Here's a picture of the primarily ecological succession, starting with exposed rocks right here, and this is over a period of time. Eventually lichens or mosses will grow on top. Eventually they will die and return nutrients to that area, kind of form a soil layer, which allows small herbs and shrubs to grow. When those die, eventually they'll get outcompeted by what we call a heath mat, which is basically more dense shrubbery, more bushes, things like that, as well as grasses. And then eventually to your jack pines, black spruces, and aspens that grow pretty quickly, are fast-growing trees and can sprout up pretty readily anywhere. And then your balsam firs, paper birch, white spruce, your heavy, thick forest community would be your final step in your primary succession, or the final stage. That would be what we call an apex community, or a complex community would be at the end of your primary succession. Some ecosystems don't have to start from scratch. This is what we call secondary succession, where some soil already remains. This is where we have some sort of soil or nutrients in the soil or in the ground that actually will help growth. That's in a terrestrial ecosystem. If it's an aquatic ecosystem, we do have some bottom sediment that's still there with some nutrients that gives us a good start, kind of a quicker start than a primary succession would. The ecosystem, usually with secondary succession, has been destroyed, either removed or somehow disturbed. That's caused it kind of set it back as far as the succession of things go to reach that apex or climax community, which you saw in this previous picture, which is actually right here, climax community. So this is what it would look like if you were looking at a disturbed land or some sort of secondary succession. You already have weeds or some sort of small growth or soil layer of some sort. That actually takes a very long time to form the lichens, growing and dying and then actually forming a soil layer. Once you already have that, it allows for weeds to come in, perennial weeds, grasses to come in, small shrubs and pines, seedlings actually happen, and then a young pine forest comes in, and eventually your mature oaks and hickory forest. So most of what you see in Onslow County, I would say, is probably secondary accession, where it used to be farm fields of some sort, and then they just stopped farming on it. There's already soil there, there's already grasses there, and eventually you can see this. Actually, a great spot to see this would be right in between here and Food Line. As you're walking over to Bojangles, you can literally see a mature oak forest, then kind of a young pine forest, some small shrubs, and then some tall grasses. And right as you get to the edge of that, you'll see the annual weeds there in between here and Food Line. So check that out next time you were driving by or walking by there. So you don't have to start from scratch in secondary succession. This is the part 2 here. Primary and secondary succession tend to increase biodiversity. The more farther along you get in succession, the more biodiverse your community is. You also increase species richness and interactions among species the farther you go in reaching that climax community. Primary and secondary succession can be interrupted by fires, hurricanes, clear-cutting forests, plowing of grasslands, invasion of non-native species, and all those things can kind of set that ecosystem back as far as secondary succession goes, and that's what really cause secondary succession to be kind of set back, pushing you further away or more primitive than that climax community. This is a part of your science focus section. It says, how do species replace one another during ecological succession? And there's a couple different ways. One of them is called facilitation. This is where one species makes an area suitable for another, but less suitable for itself. So going back to the beginning of primary succession, the lichens and mosses, they only like to survive on bare rocks because they can get a lot of their moisture nutrients from the atmosphere. When they actually grow on something and then a few of them die, it makes it easy for other species like grasses to come in and use the nutrients from their dead bodies in order to survive. And so lichens, because they are really, they keen in on some of those bare, no nutrient places, kind of lose their own habitat once they're already there because they literally die and then bring in they allow for different species to come in and make it inhabitable. Also, inhibition. This is where early species hinder the establishment and growth of other species. So, for instance, the book gives you the example of pine needles making soil acidic. Well, we know that some species of plants like more acidic soils, but most do not. And so when the pine trees actually start growing there and they start thriving, they lose their needles, they drop, and it actually makes the pH, drives that pH of the soil down, allowing for other species that are really intolerable of that to not grow there or to be kind of snuffed out before they even start germination. That's what we call inhibition. The last one is called tolerance. This is where older plants are unaffected by newer plants. For instance, shade-tolerant trees or bigger trees are okay with this. So older plants are unaffected by newer plants. Most of the time, older plants are unaffected because they grow so tall and they're first ones to the sunlight, but still those younger ones are taking some nutrients out. But that's what we call tolerance, where other species are relatively okay with others living there as long as they're not taking too much of their resource. Succession does not follow a predictable path. There is that traditional view where it goes from bare nothing to a climax community. The current view is that really it's an ever-changing mosaic and patches of vegetation, and we see that all the time throughout Onslow County. If you look around, you will probably be able to see all these different climax communities and whatnot. Mature or late successional ecosystems, again, a state of continual disturbance and change. I prefer, if you ever get a chance to see a mature late successional ecosystem, you need to go to national parks, especially out west. The redwoods, sequoia forests, those have been untouched by humans for the majority of the time, and they look so pristine and so something that you've never seen before. Very mature, late successional, and they're just very hard to find nowadays because really humans have impacted quite a bit of all the forests and land in the United States. Living systems are sustained through constant change. We call this inertia or persistence. This is the ability of a living system to literally survive moderate disturbances like forest fires, grass fires, things like that. And it might set it back a little bit, but it's still going to persist towards that climax community. Another term that you might want to know is resilience, which is the ability of a living system to be restored through secondary succession after a moderate disturbance. So not only is it going to be persistent and keep going, but it's also going to be resilient. It's going to bounce back pretty quickly through secondary succession. It's not going to take very long. And finally, the one is tipping point. This is the point of no return, where an ecosystem literally collapses. What type of feedback loop would this? I want you to answer this when you watch this the next day. See if you can tell me what type of feedback loop would it be if there was a point of no return. Think about that. What is that tipping point? How does that coincide with either a positive feedback loop or a negative feedback loop that we learned about way back in Chapter 1? See if you can tell me that during class tomorrow. Okay? That ends us with Chapter 5. Hopefully you've enjoyed it. I think it was a pretty good, easy chapter to cruise right along through, and a lot of it had been previous information for you. So congratulations. Now with Chapter 5 on Chapter 6.